This question is quite wordy. A geometric progression V has first term 2 and common ratio r. Another progression is formed by squaring every term. We've got to first show that W is a geometric progression, and then also find the value of r given the fact in the question. So if V is a geometric progression and it starts with 2, that means that the next term will be times by r, so 2r. And then times by r again to get 2r squared, and times by r again and again and again. W is still going to be a sequence, and we're going to square every term over here. So we're going to square the 2 to get 4. We're going to square the 2r, square the 2r squared, etc. And our first job is to show that this is indeed a geometric progression. So let's do a little bit of expanding. We're going to get 4r squared, 4r to the power of 4, 4r to the power of 6. Is this a geometric progression? Well, yes. The first term is 4, and after every term, we are timesing it by r squared. That means the common ratio is r squared, which means that it is a geometric progression. If we had to times by r squared and then something different, and then something different again, it wouldn't be a progression, but because it's always r squared, that's what makes it a geometric progression. Okay, on to what is actually giving us the most marks here. Given the sum to infinity of W is 3 times the sum to infinity of V, let's find the value of R. The sum to infinity is a over 1 minus R, and for V, that would be 2 over 1 minus R. For W, the formula hasn't changed, a over 1 minus R, but this time a is 4, and the R is r squared. Bit of a confusing choice of letter there. The common ratio is r squared. And if we read the sentence here, it says the sum to infinity of W is equal to 3 times the sum to infinity of V. So all we need to do is substitute these expressions in, rearrange, and find r. So this will be 3 lots of the sum to infinity of V. So 3 times 2 over 1 minus r, like this. Now I recognize this as a difference of 2 squares, so I'm going to write 1 minus r, 1 plus r. And this means that I can cancel out on both sides. We know that r has to be less than 1, so we know that r is not equal to 1. So there's no problem here getting rid of these terms. Now if I times by 1 plus r, we'll get this. Divide both sides by 6. And then subtract 1 from both sides. This is our value of r. Have a go at these two as well.